Okay, one of the homework assignment with a few application problems. First one gives us an equation for a hyperbola that looks something like this. And they want to know what is the horizontal distance in feet from the point at which the ball is thrown. I'm sorry, this is an equation for horizontal distance in feet from the point at which the ball is thrown. So x is the horizontal distance, and y is the height. So here's x and y. Both of these are in feet. Okay, it's important to understand your units before you understand what this equation is telling us. Okay, the question is, how high is the ball when it leaves the child's hand? That's this point right here. That's the point when x equals 0, and they tell us that. When you plug in 0, you get 3. So we would say 3 feet. That's the y-intercept. Maximum height of the ball in feet is this point right here, but it's the y-coordinate of that point. So we're going to need to find the vertex, basically. For this one, I guess I'll just use decimals. I'll graph this in decimals and find the maximum real quick. All right, if you do that, you can zoom out and find the vertex there. It's at 14, 17. So we want the y-coordinate for the vertex, which is the maximum height, which would be 17 in this case. So maximum height is 17. And how far from the child does the ball strike the ground? That's this point right here. And once again, I'll just find that on decimals. Obviously, I could also find that algebraically by plugging in 0 for y and solving this with the quadratic formula, or it's not going to factor, so I'd have to use the graphing calculator then in that case. I'll use decimals though to find out when it hits the ground. It hits the ground at 29.43 feet in the x. So how far would be 29.43? All right, the next problem is problem 12 then. It says your backyard is 17 feet longer than it is wide. So if this is the width, the length is width plus 17. And it gives us the area is 3,834. So we can find the width and the length pretty easily because area is just length times width. And we know the length is W plus 17. So we have W plus 17 times W equals 3,834. And this is just a quadratic that we can solve. If we distribute, we get W squared plus 17W. And if we minus this from the other side, 3,834 equals 0. I can then use the quadratic formula on this, or plug into the decimals and find the zeros. But obviously we want the positive number, not the negative one. I'll use the quadratic formula, opposite of 17 plus or minus the square root of 17 squared, minus 4 times A times C, all over 2A. And underneath the radical we get 15,625, which turns into 125 when you take the square root of it. So it's negative 17 plus or minus 125 over 2, which gives us two answers, 54 and negative 71. And obviously we want the positive answer here because the negative answer doesn't make any sense for our width. But that gives us our width, which is 54. It makes the length 17 more than that, which would be 71. But our answer is 54. All right, so the next problem then, you drive off north at 50 miles per hour, and your friend drives east at 60 miles per hour. If you both go for 3 hours, then we could get distances here, because we know distance equals rate times time. So the distance that you go is 150 miles, and the distance that your friend goes would be 3 times 60, which is 180 miles. And then they want the distance that you guys are. It says the distance between you and your friend. That's this distance. So we're going to have to use the Pythagorean theorem for that. A squared plus B squared equals C squared. And if we do that, take the square root of both sides, we should get about 234.31 miles. All right, I hope this helps.